If you live in Canada and you've looked at your bank account recently, you'll see that at some point on January 15th, you received your quarterly climate action incentive payment, or what is colloquially referred to as the carbon tax rebate. Will the rebates be enough to cover what most Canadian households pay out in carbon tax over the course of the year? That's what I'll be examining today on Green Neighbour. So the carbon tax rebates for 2024 are rolling out. These rebates are a key part of Canada's carbon pricing system, something generally referred to in economics as a revenue-neutral Pigovian tax. When the rubber hits the road, what we need to determine is whether the climate action incentive payment, otherwise known as the carbon tax rebate, equals what we pay out in carbon tax. Now, obviously, the more a household spends on oil and gas, the more they will spend on the carbon tax, and the less likely it is that the carbon tax rebate will equal what they pay out in any given year. However, the burning question in most people's minds is, where is that line? How much oil and gas can a Canadian household consume before they cross the point where they will be spending more on carbon tax than they will be receiving back in the rebate? So let's look at some numbers and do a little math. To do this analysis, I'm going to attempt to model a range of 3 different middle-income Canadian households. I'm avoiding extreme income levels at either end of the scale because I don't think that would be highly instructive in terms of telling us how the carbon tax impacts the average Canadian family. So I'm going to look at 3 scenarios, and they're all essentially middle-income families of 4 living in Ontario and receiving the climate action incentive payment of $244 every 3 months, amounting to $976 a year. So on the upper end of our middle-income family, we will have a family of 4 that drives a 2020 Ford F-150 PL. I think that stands for Platinum. It's a 4x4 pickup truck. They also drive a 2024 Toyota Sienna minivan. We're picturing a family that lives in something like a 2,300 square foot home. They heat that home with natural gas, they likely run a gas water heater, and they might even have a gas stove. According to Natural Resources Canada's fuel consumption ratings search tool, the 2020 Ford F-150 PL 4x4 burns 11.8 liters of gas per 100 kilometers. As a basis of comparison, we'll say this family drives each vehicle 20,000 kilometers per year, which is the standard frame of reference used for most new car warranties. Both these cars will drive for 200 sets of 100 kilometers. 200 sets times 100 kilometers equals 20,000 kilometers. I'm going to use these sets of 100 kilometers throughout my analysis because that's how we measure fuel economy in Canada. We talk about liters of fuel burned per 100 kilometers. Now, I should point out that at the time of this recording, the carbon tax is not yet at 17.6 cents, but it will go up to 17.6 cents a liter on April 1st, 2024. So let's calculate the gas burned for those 200 sets of 100 kilometers. We'll start with our Ford F-150. That would be 200 times 11.8 liters, which equals 2,360 liters of gas. At 17.6 cents per liter of gas, the carbon tax will equal $415.36 for the year. Now let's look at car number 2. Car number 2 is a brand new 2024 Toyota Sienna minivan. Let's assume that this car also drives 20,000 kilometers a year. Therefore, it will also drive for 200 sets of 100 kilometers. This particular van burns 6.6 liters per 100 kilometers, which blew my mind. I thought that was pretty low for a van, but that's probably part of the benefit, I think, of driving a new car. But this is, after all, our upper middle-income family. We're thinking about middle-income families. We're thinking about this family and then I'll analyze this family, and then I will analyze this family. This is our upper income family. They've got pretty new vehicles. All right, so that would be 200 times 6.6 liters, which equals 1,320 liters of gas. At 17.6 cents per liter of gas, the carbon tax would equal $232.32 to run that van. All right, so to drive these two large but not necessarily gas-guzzling vehicles, 20,000 kilometers each, a combined total of 40,000 kilometers over the course of a year, we would pay out $415.36 on carbon tax to drive the Ford F-150 4x4, and $232.32 on carbon tax to drive the Toyota Sienna minivan. That's a total of $647.68. That's not quite the total rebate of $976 a year, but we have not yet calculated the tax on natural gas for things like a furnace, a water heater, or a stove. Now, I would have loved to perform this analysis based on various home sizes and various appliances, for example, different stoves, furnaces, and water heaters, but it is extremely difficult to find that kind of data. So I'm going to base this estimate on two things. One is the average amount of natural gas that Canadian households use per month, which I'm taking from two sources. One is the Canadian Taxpayers Federation, and the second is shrinkthatfootprint.com. The second thing I'm using is the carbon tax per gigajoule of natural gas, which I'm taking from Transgas. Now, according to Transgas, on April 1st, 2024, the carbon tax will become $152.50 per million cubic liters, or approximately $4 per gigajoule. I'm going to use the gigajoule figure because my source for the average Canadian household consumption of natural gas, which is shrinkthatfootprint.com, presents a figure for average gigajoules per Canadian household, and that figure is 7.4 gigajoules per month. So we take that 7.4 gigajoules per month and multiply it by 12 to get an annual amount, and that gives us 88.8 gigajoules. Let's multiply that by $4 a gigajoule, and that equals $355.20. Let me again highlight what we are calculating here. We are calculating just the carbon tax that our hypothetical household would be spending on their consumption of natural gas. Now, that figure lines up fairly well with what the Canadian Taxpayer Federation says the carbon tax will cost the average Canadian household to heat their homes with gas this winter, which was $326. So I'm fairly content with the result of my calculations on this front. There is also the little matter of my attempt to estimate consumption amounts for three different types of households: an upper middle income household, a middle income household, and a lower middle income household. So here's what I'm going to do. I'm going to take that $355.20 figure for carbon tax paid on natural gas, and I'm going to multiply that by 1.2 for our upper middle income household. I'll multiply it by 1 for our middle income household, and I will multiply it by 0.8 for our lower middle income household. I know that's not an overly sophisticated approach, but at the same time, I think it's the best I can do with the data I have available to me. I also think it's a fair approach, and at the very least, I'm being transparent about the methodology I'm using. So you can then take my findings for what you think they're worth. I will once again remind you, however, that I am not attempting to estimate consumption for upper income families with 3 or 4 cars, a cottage, a speedboat, flights to Turks and Caicos, etc. Nor am I attempting to estimate consumption for lower income families. I mean, truly lower income families that might not even own a car. Rather, I'm trying to estimate a range of upper, middle, and lower middle income families. Not up here, not way down here. So that's why there is only a 20% difference between each of these three households in terms of their natural gas consumption. Nonetheless, that is a total range of 40% between our lower and upper middle income families. So then for our upper middle income family, we have $647.68 of carbon tax to run their 2 automobiles, which were quite new, an average of just 2 years old, and therefore fairly fuel efficient. So they benefited from that factor, but they also drove a fair amount as well, 20,000 kilometers each. My estimate for this family's natural gas use is 1.2 times $355.20, which equals $426.24. Add these two amounts together and we get $1,073.82, which is $97.82 more than the $976 that this family would receive from their carbon tax rebate in the province of Ontario over the course of 2024. All right, so this family is losing on the carbon tax, but they are losing slightly less than $100. Now let's take a look at our middle income family. In the middle range of our middle income families, we will have a family of 4 that drives a 2021 Hyundai Santa Fe hybrid and a 2016 Toyota Corolla. We're thinking of a family perhaps living in a 1,847 square foot home because that is apparently the average home size for Canadian families. They heat their home with natural gas. They would likely heat their water with natural gas, but they would likely use an electric stove. According to Natural Resources Canada's fuel consumption rating search tool, the 2021 Hyundai Santa Fe hybrid burns 7.4 liters of gas per 100 kilometers. We'll say this family drives this vehicle 20,000 kilometers per year, so it will drive for 200 sets of 100 kilometers. That would be 200 times 7.4 liters, which equals 1,480 liters of gas. At 17.6 cents per liter of gas, the carbon tax will equal $260.48. Now let's say the other car this family drives is a 2016 Toyota Corolla, 1.8 liter 4-cylinder automatic transmission, and that car drives 14,000 kilometers a year. Therefore, it will drive for 140 sets of 100 kilometers. Natural Resources Canada tells us that this car burns 7.3 liters per 100 kilometers. That would be 140 times 7.3 liters, which equals 1,022 liters of gas. At 17.6 cents per liter of gas, that will equal $179.87 of carbon tax paid to run that car. So to drive these two vehicles, a combined total of 34,000 kilometers over the course of the year, this family would pay out a total of $440.35. We will add on our carbon tax for their natural gas consumption, which would be $355.20 times 1, because this is our middle income family. So they are perfectly average in terms of their natural gas consumption. That gives us a grand total of $795.55, which is $180.45 less than the $976 carbon tax rebate this family would receive in Ontario over the course of 2024. So this family would be ahead of the game in terms of the carbon tax. Now let's look at our lower middle income family. I struggled with whether to go with 1 or 2 cars for my hypothetical lower middle income family because a truly lower income family might not even have a car. So it seemed a bit homogeneous, if you will, to have all 3 of our middle-class families driving 2 cars. However, I then realized that the number of cars isn't really what impacts this particular issue. Rather, it's the total number of kilometers driven. So here's what I did. I decided to go with a 2018 Honda Civic 2-liter 4-cylinder automatic transmission and calculate the tax on 28,000 kilometers of driving per year. Now we can think of that as 1 Honda Civic driving 28,000 kilometers. We can think of it as 2 Honda Civics driving 14,000 kilometers each. We can even think of it as 3 Honda Civics driving 15,000, 9,000, and 4,000 kilometers respectively. None of that would make a difference to this hypothetical family's expenditure on carbon tax. But it might allow this particular hypothetical family to apply to a greater variety of families out there in the real world. Therefore, this family will drive a 2018 Honda Civic or Honda Civics for 280 sets of 100 kilometers. This particular car burns 6 liters per 100 kilometers. That would equal 280 times 6 liters, which equals 1,680 liters of gas. At 17.6 cents per liter of gas, that will equal a carbon tax outlay of $295.68. So let's calculate our natural gas consumption for this family by taking our average Canadian household figure of $355.20 and we'll multiply that by 0.8. That will give us $284.16. That gives us a total carbon tax expenditure for this family of $579.84 for 2024, which is $396.16 less than the $976 this particular family would receive from the carbon tax rebate in Ontario over the course of the year. So this family would be well ahead of the game in terms of the carbon tax rebate. So in the final analysis, out of our 3 hypothetical middle-income families, only the upper middle-income family ended up with a net loss from the carbon tax, and it was just less than $100. In order to get there, that family had to drive 2 large vehicles, a Ford F-150 4x4 pickup truck and a Toyota Sienna minivan, for a total of 40,000 kilometers a year, and then also burn 20% more natural gas than the average Canadian family in order to exceed what they would receive back from the carbon tax rebate. Now, I will repeat the fact because it is important to note that this hypothetical upper middle income family did benefit from the superior fuel mileage of their fairly new automobiles, but they drove pure gas cars and they drove them a lot. So then which one of these 3 middle income families do you think would most accurately represent your family? Might your family be above any of the 3 hypothetical families I used in this analysis, or might it be somewhere below? Let me know in the comments, and of course, let me know if you think I committed some sort of grave error in my assumptions or my calculations. Thanks for sticking with this video to the end. I know it wasn't the most exciting of videos to watch, and it wasn't particularly exciting to make either, but I think this is an important topic that all Canadians need to understand. You're a trooper. Now go and have yourself a super day, and I will see you in the next one.
If you'd like to understand the logic behind a revenue-neutral Pigovian tax where taxes are essentially collected and then given right back, you could take a look at this short video right here. If you'd like to delve into the more complicated matter of how to determine the appropriate amount of tax to apply toward a negative externality, you could look at this video here.